Dear students, today we will discuss floating point notation. So in the previous modules, we have used excess notations and 2's complement notation to store the whole numbers. However, storing fractional numbers, the numbers having fractional parts, we need some other notation, and one of such notation is known as floating point notation. So you know that in binary numbers, we have learned that we have a radix point at the decimal point, and the numbers on the left side are denoting the whole numbers, and the numbers to the right of the radix point are denoting the fractional point. So here we are interested to store the position of radix or the decimal point. So this is also being used in computer science, and normally 32 bits are used. However, to demonstrate, here we will be taking only 8-bit example to make it clear. So if we demonstrate that there are 8 bits we have, so 1 bit is given to sign bit, and 3 bits are given to exponent field, and there is a mantissa field that is 4 bits in our example. So the sign bit tells us that if there is a 0 stored in the sign bit, it means that the number is positive. However, if there is 1 in the sign bit, then this means it is a negative number. And then exponent tells us that how many places are required to move the decimal or radix point, and mantissa is the actual number. So let's have an example that how a number stored already can be retrieved. So for example, we have this number 0 1 1 0 and then 1 0 1 1. So the thing which is displayed in the mantissa, that is the actual number, and it is 1 0 1 1. The exponent tells us that where we should move the decimal. At the moment the decimal is before the first one, so this exponent is 110, and this 110 is represented in excess notation which we learned in the last module. So this is 6. So in 4-digit number, when 6 is displayed, so this means you need to minus 4 from that. So actually this is 2. So this means that on this mantissa field we would be moving 2 points from this right position to left. So 1 2. So it will become 10.11, and the first bit is 0, which means it is a positive number. So it is actually displaying 10.11. So you already know that if we say 10.11, what it is representing? It is representing 1 by 2, this is 1 by 4, this is 1, and this is 2. So 2.1 by 2 plus 1 by 4. So it is giving us 4, 1 plus 2. So 2 is the whole number, and then 3 by 4 is the fractional point. So the number stored already in a computer 011010111 is actually representing 2 and 2 as a whole number and 3 by 4 as the fractional point. So similarly, you can also do another example on the same scenario. So how we are going to store the fractions? So we need to reverse the procedure. So we want to store one whole number and then 1.1 by 8. So you know, to store 1 we need 1, and to 1 by 8 you know that there is 1 by 2, 1 by 4 and 1 by 8. So 1001. So this would be the number. And you know that this number is being represented as 1.001. So as this decimal need to be shifted to the right at the end, so this means you should store here 1, which is in the excess notation becomes 1 plus 4 becomes 5. So here you need to store 5, 101, and here you need to store 1001, and as it is a positive number, so you need to store 0 in the sign bit. And suppose you want to store 3 by 8. The mantissa would be 0.011. So here is one important point, that we exclude this 0 and start saving from first one. So this means the mantissa would be 1100. It would not be 0110. And both this number 00111100 and 010001110 both would be representing 3 by 8. However, the first one is actually the normalized in this way. So such a thing is called normalized form. So if we summarize today's module, we have learned floating point notation that is being used by the computer to store fractional numbers, and we have learned about sign bit, exponent field, and mantissa.